Hello, my friends. Welcome back. We are looking at enhancing the card game war project from the WiByte Python curriculum available at www.wibyte.in. In this video, we'll look at a very interesting idea. We'll see how we can add a Joker card to a simple gameplay. Now, for those of you who have played card games, you know that Joker is this very interesting card, which can take on any value. So hence it makes it very, quite interesting in the game. Now we are going to do a similar thing in our game. Basically, we're going to add a joker in there, but there are a few steps that we must follow. First thing first, we need to add a representation for the joker. In this game, we will represent the jokers as, let's say, two Zs or two Zs, if you like to call it that way. Now, the reason I choose it this way is because remember, in my game, it's always every card is a string of two characters. So likewise for joker, the first character is always the color, the suit, and then the number. Now I'm choosing Z and Z because that's neither a color nor a number. So it's kind of like non-confusing. I just call all my jokers as ZZ. Now we are going to add two jokers to the card before shuffling. Now we must do it before shuffling because, so that the jokers also get shuffled and then they get equally distributed. But then I must add that if we add before shuffling, it's possible that both the jokers end up with one player. If you think that's a problem, well, you can say that, look, I will do it differently. I'll do it the dealing first, then I'll add joker to both the player and the computer. But make sure you shuffle them, the individual decks, once the player and computer have been given a joker. Also, in our case, we'll add the joker to the pack after the toss is done because that will keep the toss simpler. So it's as though you do the toss with the standard 52 cards and then you add these two jokers to the game, which is reasonable. We could of course add joker to the toss, but that's just going to complicate things, taking us away from the core idea that we're developing here. We are going to change the dealing to ensure jokers are also distributed because remember now the deck of cards is 54 cards, not 52. So I'm just going to change the slicing a little bit here so that the cards are distributed. Now during the gameplay, we are going to change the rules a little bit. We are going to say that if either player plays a joker, then that player wins. And if both players play a joker, then there is a war. Now this is quite reasonable because that's what the joker is. It can take on any value. So we are saying that look, the moment a joker is played, well, that player is basically winning. Now, in order to do this, I'm going to restructure my code a little bit so that it's helpful. So first thing first, I'm going to say, let me just determine the winner. And for this purpose, I'll use a function because that leads in a much neater code. And also the function can be tested separately, as I'll show you later. Once the winner is known, we will go ahead like earlier. Basically, either one player gets the cards or the other player gets the cards, or let's say there's a war. So that part doesn't really change much, but I want to just focus a little bit on how do I determine the winner. And like I said, we'll put a function for this. The way we will do this is that, well, we will figure out if either of the player has played a joker. So I just start with this condition. Look, there's a function here, determine winner with card P and card C as two inputs. I figure out if both of them are not a joker. So the reason I do this is because if neither of them has played a joker, remember if this is true and this is true, which means card P is not equal to ZZ and card C is not equal to ZZ, that means I am exactly the same situation as earlier. There was no joker to start with. I just look at the larger card and I say, okay, if my player is winning, then I return a 1. If my computer is winning, I return a 2. If both of these are equal, neither is winning, then I say, well, that's a war situation. Let's say one of the two players has played a joker. Now notice now see this very carefully. It's very interesting here. I am saying here if card P not equal to ZZ and card C not equal to ZZ, which means that the else here is that either card P is ZZ or card C is ZZ or both of them are ZZ. So which means that at least one of them has played a joker. In this case, I determine which of the two has played a joker. If let's say the player has played a joker, then the player wins. That's why it's 1. If computer has played a joker, computer wins. That's why 2. If both of them have played a joker, I return 0. Remember, this else is basically both of them have played a joker. Think through this carefully. Quite interesting. So the three return values are 1 is player 1, 2 is computer 1, and 3 is actually this should be 0. So 0 means nobody won, right? So we will fix this. Let's first build this code because like I said, we can test this separately and that's what makes it quite attractive. As before, like I said, I let the toss happen. Don't want to disturb the toss. After this, I will add the jokers to my pack. So let's just say, say add jokers. And I do that by saying, well, deck of cards dot append, say ZZ, and I'll do it once more because I want to add two jokers. don't know why the indentation is getting confused. Okay, so I'm going to do this twice to add the two joker cards. Now at this point of time, I have some food for thought for you. Why did I not do, let's say, dot append, say, ZZ comma ZZ. In fact, we have looked at this when we looked at the difference between append and extend. If I were to do this, then this entire ZZ will be added as a list to my cards. Don't want that. In fact, I want them to be added as individual items. So there was one option, the two options really. One, I could have done what I've done here. Also, otherwise I could have done an extend over here. Happy to discuss this, but for now we just stick with, let's say, this. Now, having done this, obviously my cards need to be shuffled. So I just say, because, well, deck of cards, the last two are joker now. So I am just going to say random dot say shuffle, say deck of cards. So that way the deck of cards are shuffled. Having done this, now I must enhance the dealing. So I'll say, well, look, this should be 27 and this should again be 27, because now there are 54 cards in all. Now, in fact, it's a good idea here to probably keep it as a variable that will, depending on the length of the card decks, then it's automatically done. So I don't have to do hard coding here, but for now it's okay. Now, having done this, we know that both the players and computer have been given 27 cards each. I'm going to start writing the function define the determine winner. So I'll just go back up a little bit and I'll say, okay, let me just write this function perhaps over here. Functions higher up there in the code, the easier it is to sort of read through them. So I just say, okay, let me just say def say determine say winner. And really, this is, the two inputs that I'll get is, let's say, card P and say card underscore C. Now, like I said, this part of the code is really not very different from, so let's just put a comment here, say determine, say determine the winner. Now, inside this function, I first figure out, well, if card P is not equal to, say, ZZ, and let's say card underscore C is not equal to, say, ZZ either, which means neither has played a joker. So I just put a comment here, neither is a joker. Now, in that case, in fact, everything remains exactly as earlier. So I can just go back to my code and pick that piece of code, pick that line up again. So I just do exactly this, right? So I just say, well, look, if neither has played a joker, then I come up here and I say, the player should be win. I mean, the larger card should win this. So here I just go and put, like, if let's say player card is bigger, then I just say, well, return say 1, because that's a player winning situation. I can just put this, say player 1. Elif, if the reverse happens, again I can place this here, but I will reverse this and I'll say, well, if that happens, well, return 2, say return say 2, because that's a computer winning situation. And finally, let's say else, if which means both are equal, I just say return 0, because that's a war situation. So I'll just write here war and here say computer 1. Now that was a situation when neither of them was a joker, but if I do not get into that, that means at least one of them is a joker. I just basically figure out which of the two is a joker. So I just say, okay, look, let's say, if player card, let's say, is a joker and computer card isn't, then the player wins. I say return, say, 1, because player is winning this. LF, the reverse situation, if let's say computer card is a joker, but player card is not a joker, be a little bit careful on doing this. So, computer card is a joker, player card is not a joker. In this case, I return, say, 2, because computer wins. Else, which means both of them are joker, I just say return, say 0. Now, the good thing with this approach is that, one, it's going to keep our code neater. Two, we can, like I said, test this function alone without getting into the main code. So let's just do that here. I just say, well, Python 3 minus I, let's say main, main.py. So I expect the toss to happen. In fact, this time the toss was resolved in the first attempt itself, because remember, my toss was based on two cards from the same suit. Computer has one because it's C5 and CA, but this is basically spade and club. So I'm just going to end the code right now here. I want to test this function alone. So I say determine, say, winner. Let's just take a regular case. Let's say S8 and let's say H, maybe X. Now, in this case, I expect the computer to win because computer has a larger. Okay, so there's a small mistake. I'm going to fix it right now. This is should be determine winner. Now, that's a good thing with testing this. Yes, indeed, I meant. So here I'll just take, let's just say I fix that. But right now I can just work with these three ends. Determine winner is 2 here because, well, you know, um, computer won this. But let's say now I will, let's say I make the player card as a joker. In this case, player is winning it. If I were to make both of them as jokers, then nobody won. If I were to make, let's say, the computer a joker and let's say player back to my S8 or even SA, which is a big card actually, but here joker would win because joker has got a computer would win because computer has got a joker. Now, obviously, I'm going to fix this already. So when I run this next time, I'll have to do this with run determine winner. But you can see that this code is working. And that's a good thing with making a function. It's first of all contained. Secondly, it will keep our loop neat. And thirdly, we were able to test it before the game started. And that we'll see, keep doing this. That's actually useful practice. But coming back to our main game loop, all we need to do is that we'll just put a condition over here. Having obtained the table card and having obtained the player card and the computer card, I just say, well, winner is equal to say determine winner card, say P underscore P and card C. So I said basically both of these to, let's say that function. And I say, look, if winner is equal to 1, which is the player has won this. So I say if say winner equals to 1, which means the player wins, nothing changes. On the other hand, if I say, well, if winner is, let's say, so winner is equal to say 2, which is computer win, else, which is the 0 situation, there is a war. So really the code has actually become neater. Now we can see this whole thing working. So if I did this, again, the toss resolved in one time itself. When I click the, the game, let's say gameplay starts like regular. This time computer is winning it because computer is a bigger card. Again, this time the player won. We'll just wait till we get a joker. Okay, so notice here, this time player has got a joker, computer card is C4, player is winning this. And now, in fact, joker is very much a part of our, our gameplay, right? So if I keep doing this, I think there should be some more joker somewhere, but you get the idea. Okay, again, I got a joker on the player and I got a computer card which is H5, so player wins, doesn't matter what the computer's card is. If you keep playing this, you will eventually see a war, with the joker as well. But notice again, sometimes this is very probabilistic. You may not get the exact situation, but we have already tested the code separately, and that's why it is useful to have a function over there. In fact, now this is working. So again, I got a joker on the player. So computer player wins this. Unfortunately, computer is quite lucky not getting any jokers, but you get the idea. I hope you found this interesting. This definitely adds a new dimension to the whole game. In general, if you think this way of learning works for you, where we build activities, we enhance those activities, we understand concepts by applying them, then look at our website www.wibyte.in because we have many, many, many such activities. Take care. Thank you so much. Bye bye.